Sorun olmaz. Zaten şey bekletirsin. 2-3 dakikasına başlayabilirsin. Yani baş tarafı kırpılmasına gerek yok. Olduğu gibi yayınlarız. Sorun olmaz.
Tamamdır hocam.
Tamam.
I hope you can continue.
Okay. Hello all. Today I'm going to talk about is there a relationship between COVID-19 measurements and air pollutants. First, let me introduce myself. I am Mitap Kara, studying in Istanbul Technical University Graduate School. Let's begin with introduction. As you know, in the recent years, we encountered an epidemic called COVID-19. It spread up very fast in global scale. In this period, different countries took their own bans and measurements, such as transportation bans, canceling sportive and cultural events, and applying stay-at-home ban. In Turkey, we got some measurement just before the pandemic as travel restriction. According to the course of COVID-19, our country has implemented various measurements from time to time, depending on the increase and decrease in the number of cases caused by COVID-19. In the table, you can see that time periods and descriptions of these periods. We have classified them as 3 pandemic and 2 normalization periods. Last one is 1 year round. Of course, these measurements may have resulted in human behavior and daily activity. In this context, we expect that anthropogenic emissions, especially traffic and industrial ones, changed due to lockdowns. In literature, there are many studies conducted in Turkey and global. For example, Venture have found that ground level NO2 and particulate matter 2.5 decreased, while ozone concentrations increased, according to the more than 10,000 air quality stations located at 34 countries. In Turkey, Kara et al. Have investigated by separating epidemic and normalization periods, and they found that during the period of lockdown, air pollution generally decreased by 20%, while pollutant concentrations increased by 30% during the normalization in Trabzon. Like the literature, we aim to examine effect of lockdown on air pollutant by separating lockdown and normalization period. But this study is different than the others mentioned above in terms of examining the whole provinces of Turkey. It covers 6 different periods, also compares all of the periods between each other, and stations are shown in spatio-temporal in the whole research in the full paper. Turkey is located between the continents of Europe and Asia on the Anatolian Plateau and the Thrace Peninsula. Several climate types can be seen caused by the length of the mountains and the diversity of landforms. Also, we get measurement data gathered from Ministry of Environment, Urbanization and Climate Change. Data were obtained from the 262 measurement stations located in 81 provinces, as you can see. Also, we have classified them as city, rural, industrial, and background types of air pollutant stations. And here are the measurement methods of pollutants. After gathering data, we inspected outliers and applied quality control techniques. We also inspect two-case method of data, then check temporal consistency and draw time series to see visually of every station pollutant data to check missing or erroneous data. Also, one of the important point is the ability of data sets has control to represent the selected periods. So the whole periods cannot be represented with a few of data, few of days, few of hours. So for this reason, if the percentage of the data is in a period is less than 75%, that period is not included into the calculation. The main purpose of this study is to investigate the contribution of the change in people's behaviors in their lives to air pollution in a broad perspective, together with the impact of the COVID-19 epidemic. Lockdown and normalization periods coincide with different months of the year, so this study was aimed to minimize the meteorological impact by comparing with the exact days of the previous year. Here are our results. In the first period, PM10 decreased by 4.9 from 36 to 34, while an increase was observed in 10 stations, a decrease was observed in 47 stations. In the second period, PM10 increased by 6.4% from 40 microgram to 43, while an increase was observed in the 15 stations. A decrease was observed in the 53 stations. In the third period, PM10 decreased by 2.5% from 56 to 55, while an increase was observed in 5 stations. A decrease was observed in 70 stations. In the fourth period, PM10 increased by 13.6% from 34 to 38, while an increase was observed in 23 stations. A decrease was observed in 44 stations. In the fifth period, PM10 increased by 5.8% by increasing from 35 to 37, while an increase was observed in 11 stations. A decrease was observed in 48 stations. In the sixth period, PM10 decreased from 46 to 45. So it decreased by 2.2%, while an increase was observed in 4 stations. A decrease was observed in 64 stations. In Turkey, a small decrease in air pollution compared to previous years can be mentioned. In most decline seen in the first two of the three pandemic periods, I mean first and third period. As you can see, the relative change was larger negative value. In these two periods, PM decreased by 3.5%, SO2 decreased by 5%, and NO2 decreased by 4%. However, we see that PM10 has increased 13% generally, especially in the eastern, as you can see, eastern and central of Turkey in the third wave of the COVID, which is the fourth period. In this period, while air pollution in the west of Turkey decreases, it remains constant or increases in the eastern regions, which may be directly related to climate and air temperature. Besides, Saharan dust transport events occurred in the same period. According to Köppen-Geiger climate system, cold winters are generally seen in the high mountainous areas. Humid mid-latitude, that is continental D climate characteristics, are seen in eastern Anatolia. Considering that the snow cover and the long winters in the eastern region are taken into account, the air pollution can be resulted due to the heating in this area and in this period. In the study, using large scale of data, there was no very strong relationship between the lockdown for COVID-19 and air pollutants in country scale. The reasons for this can be given as examples for each province's own ban enforcement strategy, population, geography, demographic structure, and climate characteristics. However, when the province is evaluated individually, it is seen that a sharper increase or decrease in mentioned in the literature, since each province has its own unique climatologic and demographic features. In the NO2 pollutant, an increase in concentrations was observed in the parallel with the normalization station in second period. However, while it is expected to increase in the fifth period like other pollutants, it surprisingly decreased. As seen in the another studies, the reason for this may be the process of converting NO2 to ozone by UV rays, which is the Chapman reaction from sun. As the weather gets clearer, as approaching to the summer months. In Turkey, an average of 2%. In Turkey, an average of 2% increase in PM10 concentrations in the curfew periods and 6.15% in the normalization periods is observed compared to the previous year. In SO2, an average increase of 7.56% is observed in the curfew periods and an increase of 32% in the normalization periods. In NO2, an average of 5.2% decrease was observed in the curfew periods and decrease of 2% in the normalization periods. Although the effects of the lockdown on air pollution are not so strong in some provinces, they can be seen in broad perspective. The fourth period doesn't comply with this situation, which that is, air pollution has increased despite the lockdown period. This situation may be interpreted as people's not complying with the curfew as first lockdown. However, normalization periods are more distinguishable from lockdown periods. Pollutant concentration increases in these periods were more evident, as you can see from the table. Also, due to the Saharan dust event during the lockdown, it was no positive effect on the particulate matter concentrations may have been observed, especially central and eastern regions of the Turkey. That's all. Thank you.
Dear Yiğitalp, thank you very much. Your nice presentation. The subject is very interesting and your study is very valuable. Thank you very much.
Thank you, doctor.